Hi all, welcome back. We are going to move on today from finding the nth term to using the nth term. So we're not actually just going to focus on arithmetic sequences today. We will see some of those other ones creeping in, but we will start with those arithmetic ones and a recap of yesterday. As always, in your slides there is your knowledge organiser, so make sure you're having a look at that if you need to use it to remember anything at all. You were asked as a warm-up to find the nth term for these arithmetic sequences. Remember that nth term is a position to term rule, and it's in algebra. It allows us to find any term in the sequence regardless of where it is, even if it's the millionth number. I'm just going to go through the first one using the first method that we had yesterday, though if you like the zeroth term, please do keep continuing to use that. So looking through this sequence, we've got a +2 every single time, which means it's like the 2 times table. But 2n is 2, 4, 6, 8 and so on. Our sequence doesn't start at 2, it starts at 5. So to get from 2 to 5, I need to add 3 every single time. 4 to 7 is also a +3. 6 to 9 is +3, and so on and so on. If you haven't already tried the rest of them, pause the video and try them now before I show you the answers on the next slide. So the answers to these are here. They're just going to be underlined in purple. They should be in red, but my printer is not playing ball with printing in colour at the moment. So you've got 2n plus 3, 5n plus 2, 6n minus 3 and 4n minus 7. If you've got any issues with any of those, please do make sure that you're looking back at clip 198 from yesterday and watching yesterday's video to make sure that you are up to speed. So, like we mentioned yesterday, this means that using this nth term we can find any term in the sequence given the position that we're interested in. It could be the 1 millionth, it could be the 2,364,324th, anything at all that we can come up with, but we just don't have to continue that sequence on. We can just do one calculation to help us with that. So, and we're going to start, and I'm not going to ask us to do anything as complicated as whatever millionth I just asked you for. We're going to start with the 25th number in a sequence. So, our sequence is written as 5n plus 3. This means it's 5 times the position and then adding 3 every single time. So it's like the 5 times table, but with a shift of 3. It's going to be the 25th term, so that's the 25th multiple of 3 plus a shift of 3. Sorry, 25th multiple of 5 plus a shift of 3. What we're really doing is substitution. For n being 25. So this was the nth term, I'm moving to the 25th term, so n and 25 are the same. We're going to do 5 times 25 and then add 3. 5 times by 25 is going to get me 125, plus 3 gets me 128. So 128 is the 25th term. Let's try another. So before I do this one, if you pause the video and give it a go for yourself, then you can check it against my working in a second. Okay, so this nth term at this time is 7n take 4. We're looking at the nth term being the 100th term this time. So we're doing substitution for n equals 100. Always like it when it's 100, it's a nice easy multiplication to do. So we're going to do 7 multiplied by 100 and take 4. That's 700 take 4, which is 696. So 696 is the 100th term. We're now going to move on, instead of having an arithmetic or linear sequence, to having another sequence. This is an n squared minus 3. If you're doing higher, you'll probably recognise this as a quadratic sequence. We know that it's quadratic because it's based on the square numbers. There's a squared in there. So what we're going to do is look at the 11th term. This means that n is equal to 11, and we're going to substitute in like we have previously. So this rule is slightly more complicated than the previous ones, but all we're doing is 11 squared take 3. 11 squared means 11 times 11, so that's 121 take 3, which gets us 118. This is the 11th term. If you're interested in quadratic sequences, it might be worth, particularly if you're doing higher, having a look at the other clips on Hegarty Maths that are about this. You can stick quadratic sequences into the search bar and it should come up. So let's have a look at another quadratic sequence. Again, pause the video and try this one if you haven't already. It's a slightly different question because we're asked to find the first 3 terms. Can you figure out what that means? Okay, what we're doing here is actually generating the first 3 terms of the sequence. It could be written in a different way, so we could be generating the first 3 terms. So the first 3 terms are when n is 1, n is 2, and n is 3. So what I'm going to be doing is substituting each one of these in turn. When n is 1, I've got 1 squared plus 5. That's 1 plus 5, which gives us 6. The next one is when n is 2. So 2 squared plus 5, 4 plus 5, which gets me 9. And the last one is when I've got 3 squared plus 5, which is 9 plus 5, or 14. So my first 3 terms in this sequence are 6, 9, and 14. You're given a number of questions on your slides on SharePoint to complete. Again, I'll just make sure that those are on the screen so you can have a look at them, but those answers will be on SharePoint for you to look at. Some of those are quite complicated, so I'm just going to give you a little bit of a hint for these last couple, in this one in particular. What I would be tempted to do for this one is to remember that this is 2 times n squared. We're not timesing the 2 first. You do the n squared, then double. This last one, I would be tempted to do the n squared sequence and then the 2n sequence and then subtract them separately. Quite often a table-like structure does help. The last thing that is there for you to do is to have a look again at those clips on 198. There may be some surrounding it that ask the same kind of questions, so make sure that you are having a look at those, trying to get 70% or more. And if you're having any issues, please make sure that you're emailing us. Otherwise, stay safe and we'll see you next week.